This is fundamental problem 38 from chapter 12. At the instant theta is equal to 45 degrees, we have the angle theta here, the athlete, who is here, is running with a constant speed of 2 meters per second, and we're shown the velocity vector here. So at this moment in time, the athlete is running to the left with a speed of 2 meters per second. We want to determine the angular velocity at which the camera must turn in order to follow the motion. So we have the camera down here. We have our angle theta here, and if you look back at fundamental problem 33, we were told to find the angular velocity theta dot of the radial line, which goes from here to here. So it's similar in this problem here. If we find the angular velocity for the radial line, that's theta dot, and that is also the angular velocity of the camera. So basically, we just need to find theta dot. They give you an equation here if you look at the diagram. So from here to here is 30 meters. And if you draw a right triangle like this, that would be opposite to the angle theta, and the hypotenuse is r. So the equation for r here would be r is equal to 30 times cosecant theta, because cosecant theta would be r divided by 30. And this is in meters. So we want to find theta dot. We're given the constant speed, and the speed is the magnitude of the velocity. So we know the magnitude of the velocity, and we know theta. We want to find, and we know r, where we have a function for r. We could plug the 45 degrees in and find r, and we want to find theta dot. So I have my equation for the velocity here. This comes from equation 31 in 2 dimensions, and then I'm not really interested in the velocity itself. I'm interested in the magnitude of the velocity because I have the constant speed here. So the magnitude of the velocity is equal to the square root of r dot squared plus r theta dot squared. Okay, so let's just take stock of what we have now. The magnitude of the velocity is equal to 2. Theta dot is what I'm looking for. R, when theta is equal to 45 degrees, I'm going to write this twice. So r is equal to 30 times cosecant of theta, but when theta is equal to 45 degrees, you have r is equal to 30 times cosecant of 45 degrees. So we have r, and I'm going to need r dot. R dot is equal to dr dt, but r is not a function of t, r is a function of theta. So you can say dr d theta times d theta dt. Then we can go ahead and take a derivative of 30 cosecant theta with respect to theta. So we keep the 30. The derivative of cosecant theta with respect to theta is negative cosecant theta times cotangent theta. And if you need to, you can look that up in Appendix A on page 682 of the 14th edition. But we're not done yet because this was just dr d theta, and we need to multiply this by d theta dt. But just like dr dt is equal to r dot, d theta dt is equal to theta dot. And then we can say at 45 degrees, we have, for r dot, negative 30 times cosecant of 45 degrees times cotangent of 45 degrees times theta dot. So then we can take our equation here and plug everything in, except that I don't really want to deal with the square root. So when I rewrite the equation, I'm going to square both sides. So on the left-hand side, I have the magnitude of velocity squared. That's 2 squared. And on the right-hand side, I have r dot squared. So that is negative 30 cosecant 45 degrees, cotangent of 45 degrees, theta dot, that's squared, plus r times theta dot squared. R is 30 times cosecant of 45 degrees, and then I have to multiply that by theta dot, and then square that. Okay, now I can solve for theta dot, and that gives me the answer. So if you would like to do that on your own, you can go ahead and do that and just check back at the end to make sure that you have the right answer. Okay, so if we square 2, we get 4. If we square negative 30, we get 900. And then I have cosecant of 45 degrees squared, cotangent of 45 degrees squared, theta dot squared plus 30 squared is 900 again. And then we have cosecant of 45 degrees squared and theta dot squared. I have a 900 cosecant of 45 degrees squared times theta dot squared, and here I have a 900 times cosecant of 45 degrees squared and a theta dot squared, but also with a cotangent of 45 degrees squared. So what I want to do to solve this is pull out 900 times cosecant of 45 degrees squared times theta dot squared, and if I pull that out of the first term, that leaves me with a cotangent of 45 degrees squared, and then pulling it out of the second term just leaves me with a 1. And cotangent of 45 degrees squared plus 1 is equal to cosecant of 45 degrees squared. So this is just cosecant of 45 degrees squared. And although I've been writing it like this just because I don't know, I thought it might be easier for this problem, that is the same as cosecant squared of 45 degrees. So you're squaring the whole thing. So this is now cosecant of 45 degrees to the 4th power times theta dot squared. We can go ahead now and solve for theta dot. Cosecant of 45 degrees is equal to 1 over 0.7071, and so I have, well, let's write it out first. 4 is equal to 900 divided by 0.7071 to the 4th times theta dot squared, and then solving for theta dot, we have to take the square root of 4 divided by 900. The square root of 4 is 2. The square root of 900, that came from 30 squared, so that's 30. And this becomes 0.7071 squared. And 0.7071 squared would be 1/2, so this is just 1 over 30. So finally we have theta dot is approximately equal to 0.0333, and the units would be radians per second, and this is the angular velocity for the camera.